This is the second video on scientific notation or standard form. It's a way of writing very large and very small numbers. In the first video, we looked at putting numbers into standard form, that's scientific notation, or taking them out of standard form. So, scientific notation, you write the number in the form a times 10 to the power n, where a is a number between 1 and 10, but not 10 itself. So it starts 1 point, 2 point, 3 point, up to 9 point something. And n here, the power of 10, is an integer. That is, it's a whole number, 0, 1, 2, 3, etc. Or they're negatives, negative 1, negative 2, negative 3, and so on. Examples looked at included this one, 257,000. Put the decimal point after the first non-zero digit, so it's 2.57. You then think to yourself, 2.57, how many times would I multiply it by 10 to get back to the original number? Here it is, 2.57. Shift the decimal point 1, 2, 3, 4, 5. You're back to the original 257,000. So it's 10 to the power 5. 2.57 times 10 to the power 5 is scientific notation, or another name for it, standard form. Same process, putting a number into standard form is used to take a number out of standard form. So if you wanted to reverse the process, you do exactly the same thing. Think about shifting the decimal point 5 places. So another example, there's 4,136. Put the decimal point after the first non-zero digit, it's 4 point. Think how many places do I shift the decimal point from being 4.136 to back to 4,136, and it shifts 1, 2, 3 places, so it's 10 to the power 3. So 4.136 times 10 to the power 3 is scientific notation. If you want to shift it back to a normal number, you use the same process, just multiply 4.136 by 10 3 times, shifting the decimal point. For very small numbers, do the same, put the decimal point after the first non-zero digit, so it's 2.57. Think how many places does the decimal point move between being the original number and 2.57. So here it is, it jumps 4 zeros, and then the 2 is the 5th digit it jumps. So it jumps 4 zeros, and then this 2 is jumped 5 places. It's a negative power. If the number starts at 0 point something, it will be a negative power. That's for very small numbers, a negative power. A negative power is equivalent to dividing by 10 5 times in this case. So if you took 2.57 and divided it by 10 5 times, it would jump the 2, then 4 zeros to get to 0.0000257. So very small numbers, it starts 0 point something, it's a negative power, but you count the number of digits that have jumped between the decimal point where it originally was and where it becomes in the scientific notation. Here's another example. Put a decimal point after the first non-zero digit, 4.136. From the original number, there's the decimal point, and it's to jump to after the 4 here, it's got to jump 3 places. It's a very small number, it's a negative power. And you use the same process if you to shift the number from being scientific notation back to a normal number. Now, there was also a previous video on significant figures and rounding, so what we're going to do is bring that together, because it's quite common in scientific notation calculations that you carry out a calculation, get an answer in scientific notation, and have to round it. So we're going to put these numbers into scientific notation and round them correct to 3 significant figures. So here starts 3.57. It's 10 to the power 5 because the decimal point jumped from being after the 0 here, it jumped 5 places to become 3.57, hence power 5. That's 4 digits here, 3.576, 4 significant figures. If you wanted to 3, you decide is it 3.57 or 3.58, the 6 being above 5, so halfway between 3.57 and 3.58 is 3.575, that's a halfway position. So this is nearer to 3.58. So the 6 makes it round up to 3.58 as opposed to rounding down to 3.57. This one, 9.7849, and the decimal point moved from after the 0 to after the 9, it jumped 8 digits. So that's it in scientific notation. 9.78 or 9.79 is a choice here. That 4 is the one that determines it stays as an 8. So the number that follows the 8 is less than 5. You round down to 9.78 times 10 to the power 8. Here, 9.17499. The decimal point jumped 4 digits to get to after the 9. It's a very small number, it starts 0 point something, that's a negative power. It's now 9.17 or 9.18, this 4 determines it. The 9 nines are irrelevant, it's the 4 that says keep it as 9.17. And here, put the decimal point after the first non-zero digit, 7.495. It's jumped from here, it's jumped to 6 digits to get to after the 7. It's a very small number, it starts 0 point. So it's a negative power. Notice there are 5 zeros after the decimal point, but it's got to jump that 7 as well. So that's why it's jumping 6 digits. It's now a choice between 7.49 or 7.50. This 5 makes the 9 round up, so it's 7.50. So that's, put the number into scientific notation and round to 3 significant figures. That means just 3 figures in this first number part of the scientific notation. If you click the link in the description, you'll get this worksheet. I'll have the answers with it, which involves putting these numbers into scientific notation and then rounding correct to 2 significant figures. I'll have the answers. The answers will be there on the worksheet. If you click the link in the description, there are 2 questions. This is writing scientific notation and rounding correct to 3 significant figures. The main part in scientific notation is calculations on the calculator. So scientific notation on a Casio can be entered using this times 10 to the power x button. It's not the only way you can enter it on the calculator. Other calculators may have different buttons, but the reference here is to this button or its equivalent. So if you want to enter 4.35 times 10 to the power 7 on the calculator, you enter 4.35, you press that button times 10 to the power x on the Casio and enter 7, and that's it in scientific notation. It will be displayed in that form on the calculator display. If you want to enter 2.08 times 10 to the power negative 3, you enter the 2.08, that times 10 to the power x button, and you have to make sure you press the bracketed minus sign and not the subtract sign. So the bracketed minus sign for the negative and then 3, so it's power negative 3. So that's how to enter these 2 numbers on the calculator. You'll then be asked to take numbers in scientific notation, either multiply them or divide them. So for example here, these 2 numbers, the same 2 numbers as in the last slide, are being multiplied. So you simply use this form in the calculator, enter the numbers using the times 10 to the power x button. This red multiplication sign is the multiplication button. So that's not a multiplication, it's the times 10 to the power x button you use there. So this is enter in the calculator the 2 numbers, pressing here the multiplication, and the answer may come up in standard form, that's scientific notation, on the calculator. It depends how your calculator's set. Most usually it will come up as a normal number in this case. If the numbers come very large, the calculator puts them into scientific notation automatically. You can set your calculator to scientific notation. But in this case it's 90,480. You then write that in scientific notation and that's it. So the calculator may be set to get you into scientific notation, or you may have to do it yourself. Here's the same two numbers. If you enter them but divide them, you get this large number. It will appear in the calculator display as this number in scientific notation. If it asks in the question that you should round your answer off to 3 significant figures, then it's a choice: is it 2.09 or 2.10? And it's 2.09 times 10 to the power 10, so that's rounded to 3 significant figures. So that's how to enter the numbers on the calculator. You're then carrying out either a multiplication or a division. The answer will come up in the calculator and you may have to round it. If you pause the video, you can do these questions and then I will put the answers up. Here are the answers. Pause the video to check them. And now this is the main part that we're after, which is carrying out calculations on the calculator in scientific notation, giving the answer in scientific notation, having rounded it correct to, in this case, 3 significant figures. So this says 1 milligram of hydrogen contains this number of molecules. How many molecules would be in 5 grams? So that's 5 grams, this is milligrams, so 5 grams is 5,000 milligrams. So this is 5,000 milligrams, so it's 5,000 times as many molecules. You take that number in scientific notation, enter it in the calculator, multiply it by 5,000, so that's the first line of working. You're taking this number times 5,000. Out comes the answer in the calculator. You write it down. Once the answer to 3 significant figures, the choice is 1.49 or 1.50 times 10 to the power 24, and this is rounded to 1.49 because that 3 that follows the 9 means it rounds down. So 3 lines are working when you do it. Bit trickier. Argon's a gas which contains only atoms, no molecules. So that's the mass, the weight of argon in the flask. That's what one atom weighs, or its mass is this. Now wants to know how many atoms of argon would be in the flask. So there's that mass here. That's the mass of one atom. If it said you've got 100 grams and each atom weighed 2 grams, you'd know you would divide 100 by 2 to find out how many atoms are in the flask. Well, it's the same principle, it's just awkward numbers. You would take the mass in the flask, divide it by the mass of one atom, and that will find out the number of atoms you've got. So it's a division, but you've got to divide the correct way around. You've got to divide the total mass by the mass of one atom. So sometimes we're thinking of more everyday numbers like 100 grams and an atom weighs 2 grams, you would know to divide 100 by 2. Well, it's the same principle here, just awkward numbers. You enter the numbers in the calculator, dividing them the correct way around. That's the number of atoms. 3 significant figures, it's either 6.25 or 6.26 to 3 significant figures. So it's 6.26, that 9 makes a rounding up. 6.26 times 10 to the power 20. So there's division, you've got to divide the correct way around. There's an unrounded answer and then rounded to 3 significant figures. So it's, in each question, you have to be able to enter them on the calculator. So using this times 10 to the power x button, you enter the numbers on the calculator and you're either multiplying or dividing and if you're dividing, you've got to divide the correct way around. There are several worksheets. There's this worksheet, which is exactly the type you just met, having to watch the units involved. It'll have the answers with them. So 10 questions. The answers will include the working. And then there will be other worksheets. So we've got the following worksheets. The one I did earlier, mentioned earlier, about simply putting these numbers in scientific notation and rounding them to 2 or 3 significant figures. So if you click the link in the description, you'll get access to that worksheet. Second worksheet is this one, where you're putting numbers into and out of scientific notation, and then there's multiplying and dividing, and then there's, like that last example, quite tricky questions on using the calculator. It's got answers with them. There's a third worksheet, which is the one previously shown, where you've got to watch the units, and it's got the answers. And there's a fourth one. This is speed, distance, time, and scientific notation. It also involves circular orbits, so it's got circle work c equals pi d. It's a pretty difficult sheet. So it's actual scientific calculations involving speed, distance, time, satellites, and so on, and it's got the answers with it. So it's 4 worksheets, and notes on all the number work, significant figures and rounding, which was in a previous video, and it's got the scientific notation, putting numbers into and out of scientific notation, and the 2 examples you've just seen, how to enter it in the calculator, and 2 examples of the calculations. Hope you found the videos useful. Thank you.